All right, once again, to start this out, I ask you to consider the relationship between cosine and secant. And we can also, again, say they are reciprocals. Now, we didn't really talk about it in the last video, but the reason that's important is that what we're doing is we're flipping all of our points. So in the previous video, we sort of talked about how the highest point of the cosine or sine graph becomes the vertex of that parabola-ish shape. But if you notice, if I were to take this and flip it around that vertex, that's going to give me this shape that's then confined within those asymptotes. If you look at all of your x-intercepts on your cosine graph, all of those x-intercepts become asymptotes. So what was once 0 is flipped to become undefined, and that's why we see those as asymptotes. So if we're identifying just the important information for the secant curve, we can pretty quickly see that there are no x-intercepts and no y-intercepts. So those are pretty easy to identify. The asymptotes we can go ahead and identify again. And remember, we want to try to write these in a way that would give us sort of a formula for all of our possible asymptotes. So we have pi over 2 and 3 pi over 2. Once again, those are separated by pi. So my generic formula is going to be, we'll start at pi over 2 and add or subtract pi times some number we're going to call n. Midline, once again, hopefully you're starting to see a pattern here. Our midline is still at y equals 0. The period of the function is very similar to the cosecant graph. If we look at the beginning of the period, we'll mark with a green dot. So once again, I'll actually just do an asymptote as the beginning of a period. And then the end of a period is going to have to occur after we have gone through and included one of each curve that goes up and down. So that puts us at this asymptote being the end of our period. So the distance between those, so we go from negative pi over 2 to positive 3 pi over 2. That is a distance of 2 pi. So this period is also 2 pi. And then amplitude, just like we said with cosecant. Technically, there is none. But if you said 1, because you're looking at how high above the midline or how low below the midline is that sort of vertex of your parabola-ish shape, you could say it's 1.